My name is Petersen and I'm one of the 10 PhD students in the European Union's Marie Curie Doctoral Network, HOMTech. I'm working at the Technical University of Denmark in the Fiber Optics, Devices and Nonlinear Effects research group. My project is about higher order modes in rare earth doped fibers that can, for example, be used to build fiber lasers or optical amplifiers. These doped fibers are usually single-moded and just support one mode of light, and the aim of my project is to investigate the effects of also allowing a few higher order modes to propagate in those doped fibers. Here, for example, I have an erbium doped fiber, where the core of the silica fiber is doped with erbium ions. If the light from a pump laser with the right wavelength enters this erbium doped fiber, then the erbium ions can absorb incoming photons from the pump laser and transition to a higher energy state. The excited ions then quickly drop to a lower but still excited energy level. So the erbium ions in the fiber basically store some of the energy that comes from the pump laser. If a photon with the energy that matches the energy difference between the two erbium levels arrives, then the process of stimulated emission can occur and create a copy of the incoming photon, while the excited erbium ion de-excites to a low energy level. For erbium, light around a wavelength of 1550 nanometer, which is infrared and not visible, can be amplified. This is especially useful because normal silica fibers have the lowest loss in this wavelength region, and most optical communication takes place around this wavelength. And because this process of stimulated emission takes place multiple times along the fiber, the output signal can be more than 1,000 times stronger than the incoming signal. There are multiple ways to excite a specific higher order mode in a few mode fiber. One way is to use a spatial light modulator, where the phase of the light can be changed arbitrarily. This is especially useful for experiments with multiple higher order modes, because it is easy to change between them. Another way to excite a higher order mode is to inscribe a long period grating into a fiber. Here we can, for example, thermally inscribe a periodic pattern that can excite higher order modes where the period matches a specific mode and wavelengths.